Hi, welcome to Chapter 3, Lesson 4, or our last lesson for this course. That's entitled Area Between Curves. So our goal for this lesson is that at the end, you must have or you must be able to compute the area between two curves using integration or integrals. So, what do we mean when we say area between curves? So, for example, if we have the function f of x and g of x, which are both continuous functions on the given interval ab, so we assume that f of x is greater than g of x. So, the area between the two curves on the given interval ab is given by area equals the interval of area equals the integral of f of x minus g of x dx from a to b. Now, the graph would look like this. Since f of x is greater than g of x, that means f of x will be on a higher position than g of x in our graph. So, the shaded area here, which is represented by a, okay, can be solved by the integral of f of x minus g of x dx from a to b. So take note, f of x is our upper function while g of x is the lower function. So this would also may change if in case g of x will be greater than f of x. So if that's the case, so g of x will be on top or the upper function and f of x could be the lower function, you simply reverse the positions of f of x and g of x here. Okay, so let's have some examples. So for example number 1, we are going to determine the area between the curves f of x equals x plus 1 and g of x equals negative x minus 1 on the given interval 1, 5. So to do this, we have to take any value between the interval 1 to 5. So for example, we will use x equals 3. Again, you could use any other number between the interval 1 to 5. You could use 2, you could use 2.5, you could use 4, as long as it's a number between the interval. So for instance, we use 3. So first, we substitute 3 to f of x. So f of 3 will be 3 plus 1, or that is equal to 4. Next, we substitute the same number to the other function. That's g of x equals negative x minus 1. So that's g of 3. So that would give you negative 3 minus 1. That's negative 4. So since 4 is greater than negative 4, it follows that x plus 1 is also greater than negative x minus 1, which means that x plus 1 will be our higher function or upper function and negative x minus 1 will be the lower function. So we can now get the area of the region between the given curves. So to take the area, we get the integral of x plus 1, that's our upper function, minus negative x minus 1 dx, that's the lower function. So from 1 to 5. So that is our given interval. So we simplify first. So this will be integral of x plus 1 plus x plus 1. So we simplify. Further, that's 2x plus 2. So that's integral of 2x plus 2 dx from 1 to 5. So we can now get or evaluate the integral in our example. So that's x squared plus 2x from 1 to 5. So first we substitute 5. So that will be 5 squared plus 2 times 5. Then subtract and we substitute 1. So that's 1 squared minus 2 times 1. Simplify. 5 squared is 25 plus 2 times 5 is 10 minus 1 squared is 1 minus 2 times 1, that's 2. So simplify further. That's 25 plus 10, that's 35, minus 1 minus 2, that's negative 1. 35 minus negative 1 is 36. So, therefore, the area between the given curves is 36 square units. Remember, don't forget your unit of measure. Since this is area, we will use square units. Let's now have the second example. So we determine the area between the curves y equals 4x plus 3 and y equals 6 minus x minus 3x squared on the given interval -2, 0. Again, we have to determine first which among these two functions is the upper and the lower functions. Again, and to do that, we have to take or select any number between our given interval, that's -2, 0. So, in this case, we will take x equals -1. Again, you could use any other number as long as it is in between the given interval. So, for instance, we have -1, so that would give us, substitute first to 4x plus 3, that's 4 times -1 plus 3. So, -4 plus 3 is -1. Next, we substitute -1 to the other function. That's 6 minus x minus 3x squared. So, that will give us 6 minus -1 minus 3 times -1 squared. So, simplify. That is 6 plus 1 minus 3, or that will give you +4. For this instance, the second function, 6 minus x minus 3x squared, is greater than the first function, which is 4x plus 3. So since the second function is greater, the second function will become our upper function and 4x plus 3 will become the lower function. So get the area. We have a is equal to upper function, that's integral of 6 minus x minus 3x squared, minus the lower function, which is 4x plus 3 dx, from -2 to 0. Simplify, that will give you integral of 6 minus x minus 3x squared minus 4x minus 3 dx, from -2 to 0. Simplify further, this is 3 minus 5x minus 3x squared dx. So that's again from -2 to 0. So get the integral of the given function. So that's 3x minus 5 halves x squared, or 5x squared over 2, minus x cubed, from -2 to 0. So we have to substitute each of the values in our upper and lower interval. So substitute 0 first. So that's 3 times 0 minus 5 halves, 0 squared, minus 0 cubed, minus 3 times -2 minus 5 halves times -2 squared minus -2 cubed. Simplify. The first series of terms will all be 0 because this is 0 minus 0 minus 0. Minus 3 times -2, that's -6, minus 5 halves times -2 squared is 4, minus -2 cubed is -8. Then, simplify further, this will be 0 minus -6 minus 5 halves times 4 will give you 10, minus -8, that will be +8. So, that's 0 minus -6 minus 10, that's -16, plus +8, that's -8. So, 0 minus -8 will give you +8. Therefore, the area between the curves is 8 square units. So, if you want to review some of the linked lessons, I will put that in the description box below. So I'll see you next time. Bye!